Cool, we're 5 minutes ahead of time, which I'm probably going to eat up. Hi everyone, in case you forgot the blur of intros, so my name is Alex, I'm A-North on the Slack and GitHub. I write lots of FIPS and do protocol design for Filecoin, so making Filecoin faster, better, cheaper, all those things. There's lots of work for us to do along all those dimensions. I'm going to briefly talk about the things that were discussed at Singapore a couple of weeks ago in a similar venue. I need to be fairly brief here, so these are very high-level summaries. The status of most of these things is ideas or proposals or analyses or ways of thinking about things. So I'm not going to give you a lot of background, but don't encourage you not to get too worried that these are decisions or things that will happen. This is a venue for discussion. This is the opening of the discussion, not a summary of the closing of the discussion. So I think I've got 5 sort of topics that were touched upon, which I'm going to try and summarize for you all here. There was much more than I'm going to be able to summarize, but videos of all of those sessions are available online, and I'll have a link for you to those at the end. All right, so one topic that's covered is improving storage utility. So utility of storage here, useful storage here, means storage that can be used for putting data in. So there's useful storage is also used in the context of incentives. So I'm not talking about the incentive mechanisms here, but the ability to put data into sectors and get it back out again. So there's an idea here that storage is a service and can be abstracted from the physical realization. If you think about a hard disk and a file system is an abstraction over storage of data as a developer. You write bytes to a file, read them back out of a file. The linear nature of a file has no bearing at all to how data actually is represented on disk. A file system implementation and a disk controller and a disk drive will do various types of remapping the data, moving data from bad to new sectors, sharding the data, backups, or not backups, but error checking bits and things like that. You, as a developer, as a programmer, you just want to write bytes to a file, an abstract file, and know that they're there. And that is analogous to what consumers of a storage service want. As consumers of a storage service want to put data with a provider into some sectors, and know and have certain guarantees about how that data will be persisted, and they don't care about which sector it's in, or whether the data moves between sectors, or whether there's some abstraction between the utility of the provision of a storage service and the implementation of that physical realization of that utility. Filecoin right now has these two things tightly coupled, and there's room for us to give SPs more flexibility while improving the ability of for them to provide a good service. So this storage utility is fundamentally comes down to the ability to read, write, and update data in physical media. And as a mental model to try and have, a first level, first analysis of this might think that if we make it easier for providers to read, write, and update data in sectors, then that'll be better. That'll provide better service for clients. But it's not quite that simple because we work in a decentralized, low trust environment. If storage providers could arbitrarily update data in sectors, then after they prove to you that they've proved to a client that they've put data in a sector, they can replace it. And that's not what that client wants. The client wants the data to stay in the sector. And so in this decentralized setting, the utility that the Filecoin network provides is restrictions on the storage provider's ability to arbitrarily update data in their sectors. So there's a balance for us to strike here between making it. There's two things we want to achieve. We both want to achieve much easier, cheaper, faster updating and reading and writing of data into sectors, and also very strong guarantees that a client can rely upon that data can't be removed from a sector afterwards. For some duration of time, for some under some known parameters, the data can be changed, and outside of that set, it will not be. So there's a thesis here that the minimal functionality that the Filecoin network needs to provide at its core layer is to be able to mediate and enforce commitments to storing data for some duration of time. And that upon that, people can build applications and data DAOs and all kinds of storage-related things on top of that service of committed data. So there's a path, a few things we need to do to get there. One is direct data onboarding, which is currently open as FIP 76. A follow-up to that is to allow notifications of data commitments to user actors. Commitment here, sorry, it's overloaded term. By commitment here, I'm mostly talking about a logical agreement, a logical commitment to put data in a sector for a certain unit of time, not just a commitment, not just a hash, not just a cryptographic commitment. So notifying user programmed actors of commitments. So currently, the built-in storage market is the only way to, is privileged as the only smart contract that gets told when data is put in sectors. We want to open that up to any smart contract to receive a synchronous on-chain trusted notification whenever data is put into a sector. And that can then be used to build markets and data DAOs and things like that. There's currently a coupling between sector commitments and data commitments. I'll talk about that in a second. And we're also missing the ability to update sectors, to replace data that was already in a sector, and then move data between sectors and delete data. Decoupling commitments is a proposal from Singapore to change how commitments work, and that is to remove the concept of sectors expiring, except perhaps at their sort of 5-year lifetime limit that exists for PORIP security, and instead have commitments to be data. And so the idea is that when sealing data into a sector, the sector is going to live forever. The data comes with a commitment to store this data for 1 year or this data for 3 years. And then after that commitment has expired, the SB can replace the data, and they can make a new commitment, just a new data to a new client for a new term. This would also make it okay to move the data commitment to a new sector under the same minor actor. The commitment is not to store the data in this sector, is to store the data in a sector. And we can on-chain recognize the movement of data between sectors. This would allow committing to data for longer than the lifetime of one individual sector. You can make a 10-year commitment to store data, even though sectors only live for 5 years, because that commitment can be moved to new sectors in order to maintain a continual 10-year commitment. Okay, on a totally different topic, path to scaling. So scaling the Filecoin network means, dumb it down a lot. It means more sectors and more data and more transactions about those things. There are fundamental bottlenecks to what the current network can do on both those things. The biggest bottlenecks are the chain bandwidth, so it's the compute and I/O associated with block validation, and the size of the state, the size of the blockchain state, which is replicated by all validating nodes. There are lots of ideas about how to solve various parts of this. I've skipped over most of the building blocks to state one proposal, which is a synthesis of a few ideas, which is to firstly take per miner state off-chain. So that dominating almost all of the Filecoin chain state is sector accounting. It's metadata about what's in each sector, how long that sector is committed for, what pledge and termination fee parameters that sector has. That's almost all the data. So take that off-chain and move it into a private, unobservable state, but have verifiable computations over that state. So essentially means turn each miner state into a rollup. And then secondly, shard this state. So rather than having single miner rollups, have subnets each compute a rollup, or essentially a rollup of a power table in a verified computation. So if we split the network into subnets, each of which performs a verifiable computation, which forms sort of a subset of a power table, and then mainnet is reduced to verifying those power tables and distributing block rewards to the subnets for them to do as they wish internally. This removes a huge amount of functionality from mainnet, as in work that mainnet needs to do in order to maintain Filecoin. All that mainnet would need to do is, mainnet would not need to have any trust in how the subnets work, except that which you can verify through the roll-up computation. So in particular, subnets would be free to operate any consensus algorithm they want. A subnet could be entirely proof of authority. A subnet could be one network, one single miner. A subnet could be geographically constrained and run an extremely fast consensus algorithm inside one data center. We should be able to construct mainnet to not care about any of those details and only care that it can verify the computation of the sector accounting. The way to do that will be some extremely complex SNARK computation, which is a big open research problem, or research/engineering problem. Yeah, I think that's it. So this is a direction, right? There are definitely unsolved parts of this problem, but it's a direction which could lead to an arbitrarily large scale for the network. All right, sorry, I should have clicked this before. Right, so yeah, mainnet doesn't need to trust anything about subnet nodes. One thing this does need is that this needs a timestamping service. The one thing that's very hard, the first thing that would break in this idea is that a subnet could collude to fake window posts. The whole point of window post is that it's a regular every 24-hour check on every sector. There's no point letting a roll-up go for a whole week and then do all their window posts at the end. That wouldn't fundamentally prove the continuity of storage. So we need a timestamping service that can be trusted to say that this window post proof was definitely made before this time, and then we can then verify that the checks were made at the appropriate time. Now this turns out to be not too much of an ask, because there are other things that also need timestamping services, and we could use the same timestamping service for those as well. One of those things is fast POREP. So very brief, the reason that sealing takes a long time and is extremely computationally expensive is because is to make it hard enough to is to make it impossible to fake storage and still answer the window post and winning post challenges that prove the storage is online. So to massively simplify things, POREP is slow in order to make storage, faking storage impossible, given the 30-second epoch time that winning post, excuse me, the winning post consensus check does. Hypothetically, if our block time was 1 second instead of 30 seconds, sealing could be 30 times faster. Unfortunately, 1 second global block time is basically impossible to reach in a decentralized network. But luckily, we have other ways to get there. So the polling time, so polling time here means the challenge time for winning post. So it's at the beginning of an epoch, DRAND emits a beacon, and that informs the SP which sector they need to sample, which piece of data they need to sample. And then the end of the epoch, 30 seconds later, they need to distribute a block with a proof that they have that data. So this 30-second polling time is the duration between a challenge and a response to prove storage. If we make that polling time shorter, we can make sealing that much cheaper, which makes unsealing that much cheaper, which gets us to fast retrieval. So how can we shorten that polling time? DRAND gives us the beginning of a window. We need a way to get the ending of that window be much shorter. One way we could do that is with a timestamp service. If a node could receive a DRAND beacon and then get a verified timestamp of their challenge response 1 second later, excuse me, then we could have fast POREP and fast unsealing without the need to change the epoch time for Filecoin. So this is another piece of research and engineering that we need to complete, but this is a direction towards getting much faster unsealing and hence much faster retrieval native to the protocol. Thanks, Kuba. Yeah, thanks. Final thing, I think. Okay, this was not one theme, or not one topic, but a theme that emerged multiple times throughout different discussions in Singapore. But there are multiple things that point to advantages if we simplify the protocol. Let me back up. There's currently 2 ways to onboard data to Filecoin. One is to seal data into a sector and prove that sector in one operation. And the other way is to seal a CC sector and subsequently put data into that sector with snap deals. So there's 2 ways to achieve the same outcome or similar outcome. This second way has many advantages, but is currently more expensive in gas than the first way. The first way essentially exists as an optimization. However, this sealing data into sectors directly slows down, is complicated for sealing as a service pipelines. Shipping the data back and forth from the SP to the sealing service is complicated, and complicates their protocols and expensive. If we did always have CC plus Snap, there are various proof of access protocols we could add on top of this that make it cheaper to make it possible to prove access to data independently of proving storage. And also, only the second path leads to updatable sectors. Unfortunately, the first path, the data is not updatable. Question?
Just this dumb question. What's CC stand?
Sorry, committed capacity. It means an empty sector. That's a sector that's provably empty. Empty meaning full of zeros. So directing here, if we optimize the CC plus Snap path enough, perhaps we could drop support for the sealing data path. If we got the cost difference of those to be close, we could justifiably drop the slightly cheaper but less functional version and have exactly one way to do it. And so some things we need to do there are proof aggregation for Snap deals, which thing we know how to do and is coming soon. And remove what currently exists as an accidental subsidy in the single sector proof. Single sector onboarding is currently subsidized by Cron, which is another advantage to the existing method.
Can you expand a bit more on the second point? CC plus Snap could support fast access of, like proof of a fast access.
Sorry, could you hold the mic a bit closer?
Can you expand a bit more on CC plus Snap could support fast proof of access?
Yeah, I probably can't. There's a video from Peter Robertson from Singapore, which explains it in a bit more detail. I don't think I understand it deeply enough to do so, but I see other hands. We've only got 2 minutes left, so yeah.
Just an answer for you. We can cover the proof of access thing later in the workshop. Yeah, after 2 talks.
You talked earlier about sort of splitting up or making commitments about data instead of sectors or capacity. How are we going to do it with network security? Because there's a problem where like people commit data, or basically commit to store data for a long time, and that gives them a stake in the network, which means they won't misbehave. But if they could just like, was the proposal here to make it so they could delete this data at any point in time if it's just a commitment, or was that not the case?
No, there needs to be some economic penalty for breaking the commitment.
Okay, got it. Makes
Details to be figured out, something like the termination fee that exists today.
Okay, but it could be a lot simpler because it's not. Okay, that's
Yeah.
that's nice.
Okay, there was one other slide that I forgot before, is that right? Yeah. There's also a bunch of talk about various economic opportunities and issues in the network. Discussion about the baseline function, which influences lots of things in complicated ways. And sort of questions about whether it's the exponential is with its current parameters, is the appropriate baseline function. Discussion about termination fees. There's the fundamental trade-off between size of the network and stability of storage that's on the network. Essentially, if it's cheaper and easier to put data on, then we can have a bigger network. If it's risky and expensive to put data in, we'll have a smaller but more stable network. There's biases between sectors, a discussion about biases that cause some sectors to be preferred by an SP than others, unrelated to their utility to clients or the network. Discussion about the role of protocol incentives, so that's probably a bit vague, referring here to verified data and the Filecoin Plus program. What's the role of those things in the network? Discussion about locking, perhaps counterintuitively, a high rate of locking network-wide is probably very good for long-term SP economics, but it's not obvious because high locking is a short-term cost to SPs. And then a review of consensus security, what secures our network against attacks. There are two components: the physical cost of hardware and the computations that are required, and the monetary cost of pledge. Right now, it appears that the pledge provides most of the network security, hardware providing a small part. There is room for us to room for us to improve both of these or change both of these or design things to move more of the security burden onto storage. Right now, there's just not physically enough hardware on the network for it to provide good network security. But if we can see a path to 10 or 100 times more hardware, then perhaps we could move the basis of security more into hardware than pledge. Okay, there's a summary, a very brief summary of a couple of days of content. All of the sessions were recorded, they're available online. You probably don't have time to watch them, tonight before for more discussions, but you can find them all on the Filecoin project YouTube.